All right. Got my buddy Eric here.
Hello.
Hello. This is Mr. Millhop. Hey, we're going to go over some questions from our Unit 1 post-test. So good review. All right, number 5. Okay, Eric, what are these bars there? What does that mean?
Doesn't mean like it's positive, everything in it.
Okay, yeah, everything in it's going to be positive. What are they called, though?
I don't remember.
Absolute value.
Absolute value.
Absolute value, yeah. Okay, so the key with these is we want to get this stuff all by itself first. So I'm going to rewrite just so we have some space to work. What's in the way of it being all by itself? Like, what is at least one of the things that's in the way?
-3.
How do we get rid of that?
Add 3.
Do it. Nice. So write that next step. What it would be.
So wouldn't it be, and then you would
Good.
subtract this thing?
Common mistake. These absolute value bars, they kind of act like parentheses. Like they're more powerful parentheses. Like parentheses just say, hey, let's group this stuff. These say, yeah, let's group it, but also let's make it all positive. So like if I had, we go on this side here, if I had 3 like this, does that mean 3 plus that?
That means 2 times. So
Same
you
thing
would
here.
distribute the 3?
No, we want to get rid of it.
Oh, okay.
So what do we, other than multiplying it through, how do we undo that?
Divide.
Okay, so that would look like this, right?
Yeah.
Mr. Germanis, you want to join our video?
No, thank you.
What's that?
Am I in
No, it's okay. What's that?
Do you know Michaela Walker?
No, hello, Michaela.
She needs to make up a test on Monday.
Okay.
But I don't want her in the classroom while she's
What period?
First period.
That's fine. Planning, totally good.
Oh, okay.
Yep.
Can she take her
For sure. Yep.
test in here? Yeah, she can have so much time.
No problem.
Thank you so much.
All right. All right, let's keep going.
Alright.
So this one's easy. What does that simplify to?
And that'd be 7.
7. Okay, so it equals 7. So put it equals 7.
Below?
Like, yeah, like we'll write our next step, like equals 7. Okay, what's left on the other side?
1, wouldn't it be 1 minus, and then a fraction, 5/3.
No. So just like if we go back to here, if we divided this by 3, those cancel out,
Yeah.
and all that stuff's
Oh,
left
it just
over.
stays the
It's the same thing.
Okay, so it'd be,
Okay, absolute value bars are still there.
uh,
We're almost done. Now is when the idea of this always being positive comes into play. If all of this stuff simplified to 7, it would be okay, right?
Yeah.
Like if we plugged in something for m and we got 7, absolute value of 7 is 7. We're
Yeah.
good. What else could that simplify to and have it still be true?
what do you mean?
Like what else could be inside there, all simplified, that would still
2?
be equal to
Yeah.
7? Like what if all that stuff, like we plugged in a number for n, simplified it, and it came out to -7? Would that be okay?
Yeah,
Why?
because it's still positive.
Yeah, absolute value also makes positive. So this stuff can either be 7
Or
or -7. That's why we take this and we go, well, this stuff can either be 7 or this
Yeah,
stuff can either be -7. Does that make sense?
Yep, and is that it?
Yeah. And from there, do you feel good about solving those?
Like factoring it?
Well, no, we're not factoring.
Or what do
Like working down so it's m equals
Oh,
and n
yeah.
equals. Like subtract 3 on the other side
Yeah, yeah.
and divide. We're done.
Okay.
Cool. So let's try number 6.
Okay.
Let's get a little. We'll just come down here. So absolute value 4x minus 1 equals 2x plus 9. Okay. What are you thinking first?
The absolute value is already by itself.
Sure. So do we really have to do anything?
No.
Like what we did up here?
No.
No. So what does that mean we get to do?
Do we just divide it now? Or
Like what did we do up here when we had the absolute value by itself?
you got the 2.
It could either be positive
Or
this
negative.
stuff or negative this stuff. Same thing here. It could either be positive this stuff or
Or
negative this stuff.
Mhm.
So positive would be just positive, right?
Mhm.
Or
Minus 2x minus 9.
good. Hey, explain to me while I write it. Explain to me how you got that.
Like,
Like, why are they both minus now?
because it's one is positive, one is negative, right?
Like positive and
Yeah.
negative. But how come? You're correct. I'm just trying to get you
Yeah.
to explain more. Why are they both negative? Why not just minus 2x plus 9?
Because they're both this part of the solution. I don't know
Ah,
how to explain
yeah.
it.
That was actually pretty good. Like, they're both, we want to have minus both of those terms,
Mhm.
which in your head you did the quick distribution and it was good.
Mhm.
Yeah, that was good. Okay.
Okay.
Could we solve those pretty easily?
Yeah.
Do you want to race? No, we won't race. Just pick one of them to solve and finish out.
Like just
Either
like
one.
subtract 9,
Yep.
subtract 9.
Get x by itself.
And then minus 4.
Mhm. Oh, all the way. We need to know x equals
Oh, okay.
what?
5. Wait,
Yep, show that last step.
so then it'd be,
Divide by negative 2. Yeah, good. You got it.
and then so it'd be negative 5.
Mm.
Oh, let's be 5.
Good. Nice. Now, would we get 5 over here also?
Yeah. Wouldn't it be positive or negative?
No, not necessarily.
Oh,
It may be 5. It may not be 5. It's going to be some number though. It's not necessarily going to be the same number.
oh, okay.
It'll just be whatever would make this true.
Oh,
Like it's
when you
complete.
plug it back in.
Yeah, it's a completely new equation. Who
Oh,
knows
okay.
what the answer could be? It may be 5. It may not be 5.
Mhm.
Good.
Yep.
We got one more. Let's fit it on here. Number 9. So number 9 is rational equations.
Mhm.
These are all big fractions. What do we want to have with fractions?
The same on the bottom.
Same. What's the nice word?
Denominator.
Good. Same common denominator. So let's find a common denominator.
Wouldn't it be 6x squared?
Yeah. How did you? You're right. How did you get that?
Because there's already like 2 of them are that, so you just need to get one. There to
Yeah,
have a
and-
common denominator.
I think we can get that to be
Yeah.
that also. So, what would we need to multiply this 2x by to turn it into that?
3x
Yeah, right. The 3 to give you the 2.
and the
And
x
the-
to give you the square.
Good. Okay. So we'd have something like this. That's not going to change because we already have the right denominator. Equals 1 over 2x. And you said let's multiply it by 3x.
Yep.
Like that?
Mm-hmm.
What do we have to do it to top and bottom or just the bottom?
Just the bottom right. Or is it? No, top and bottom.
Good.
Since we're
Yep.
multiplying both of them.
Why top and bottom? That's the tough question.
Whatever you do the bottom, you have to do the top.
True. Why? That's even a
I
harder
don't
question.
really know yet. I just
What is 3x over 3x really?
one.
1, right? You should probably remember this in class.
Yep.
It's big ugly 1. If I multiply something by 1, does it really change its value?
No.
No, it stays the same.
Yeah.
It's going to look different
Mhm.
because we're using an ugly 1, but you're allowed to I could take this and multiply this by the whole quadratic formula over the whole quadratic formula,
Mm-hmm.
and it would look ridiculous, but it would
It's-
be okay
yeah.
because it's 1. So 1 over 6x squared equals, what do we have on the top here?
3x.
Yeah, easy. And on the bottom we have what we wanted,
X squared.
plus 7 over 6x squared. Now what do we, so we got all the same.
So then wouldn't it just be 1 equals 3x plus 7?
Good.
And
Can
then,
we finish that in our heads?
yeah, subtract 7.
So subtract 7, negative
Negative
6.
6 equals 3x and it'd be negative 2.
Good.
Okay.
Sound good?
Yep.
Okay. Nice job.
Thanks.
Eric, give a thumbs up for the video. Awesome. All right, bud.